Here I have a couple of problems in which we need to determine what reagents we need to use to accomplish that transformation, to go from here to here. And same thing in the problem below. So let's get started. What are we doing here? This is cyclohexane, and we have added two substituents, bromine and OH. Notice that they are anti. One is above the plane and one is below the plane. So what can we do to do that? We know that we can do a reaction through bromonium intermediate that will give us the selectivity, stereoselectivity. So how do we do that? To do a reaction via bromonium intermediate, that will get me to the product if I do bromination with water. But I need to make an alkene out of that to do the bromination. So how do I do that to make an alkene out of that? Oh, I forgot something. That my problem originally did have a bromine. So we can do that, but previously, if you are in Orgo 1 class, you probably don't know yet how to do that, but via radical reactions, we can do it, which is what I had first, but I omitted that. We can do this with bromine and light. But let's take it from this point. So if we started from cyclohexane, then we functionalize and do the bromination first. Now, starting from bromocyclohexane, if I need to go here, to actually have an addition via bromonium intermediate, I need an alkene. And so in the first step, I need to perform an elimination reaction. In that elimination reaction to take me to the alkene, so let's say that I use sodium methoxide, one example of base that I can use. And in doing so, remember that here you have alpha, carbon, beta. These are beta elimination, and you will form your pi bond between the alpha and beta carbon. Now you have an alkene. Now we are closer to that. What we need to do now is an addition to double bond, but we have to ensure that these two are anti-opposite. And the way to do that, we use the via bromonium intermediate. How we do that? If we add bromine, but instead of having an organic solvent, we do that with water, we will get the following intermediate. Let me draw the intermediate first down here, which is your bromonium. In the bromonium, you have this cyclic structure, right? And then because this is not HCl, this is water. That's what I meant to write. So, water. And water being my solvent is much more abundant than bromide, the counter ion. So I will have let me do the arrow to the other carbon. So that is identical to the product that you have. So under, and then you open that up. And that way we'll get the OH at the bottom and the bromine up. But of course you can have the enantiomer to that. So because of that mechanism, every time that we have intermediates like that, bromonium, epoxide, or when you do the oxymercuration, you get those intermediates. In the next step, you do the attack from the opposite side of that little cyclic structure, and thus the stereochemistry, the mechanism is anti. So you get the two substituents in opposite sides. So that's why we said. So in going, if you were doing that from cyclohexane, then you need to get first a good leaving group. So you do the bromination, that's via radicals. So depending on if you have seen that or not in your class. But if you haven't seen that, let's say, let's take it from here. And so the alkyl halide, you can undergo the beta elimination, form the alkene, and then via bromonium, this is your intermediate, and that's the final product, right? I just wanted to draw the intermediate. Okay, so let's get to the second problem. What do we have here? I have an alcohol, and now I have two alkyl halides, and apparently we're always going to get a mix. So we're going to get a mix of products. So we need to now remove the alcohol and then add bromine to that. That means we need to do an elimination reaction and an addition reaction. And so, but to do an elimination reaction, remember that OH is a terrible leaving group. So our first step would be transform that into a better leaving group to do an A2 elimination. So I'm going to use tosyl chloride to change this for the following OTS. Then notice that I have added the bromine in two places. So like here and here, which means when I do the elimination, I want to do the elimination in these two positions, not terminal. Because again, when you do beta elimination, this is a alpha, beta, and beta. So I need to choose a base such that I favor the side product. And that is using a small base. So I'm going to go over here. What is a small base? You can use here butoxide. You can use methoxide. If you use a bulky base, you're going to get a different product. So here you get the side product, which is this. And I'm going to draw what you would get if you use, say, a bulky base. If you use, instead of ethoxide or methoxide, you use terbutoxide, potassium terbutoxide, for example, then the Huffman product is preferred. This is called the side step. And if you use a bulky base, you can also use other bases. But let's say now we're doing to the terminal, the Huffman product. And I don't want that because that's not going to get me to the final product. Because at the end of the day, I know that I need to do later an addition. And if I do an addition, I'm not going to get the bromine where I need to. Because if I do an addition from the terminal alkene, I will have a different outcome. However, if I do my elimination in such a way that I get the size of product, now I can do an addition reaction. And notice is here, the two carbon atoms at the double bonds are equally substituted. So there's not such a thing as less substituted or more substituted. So we don't need to talk about Markovnikov or anti-Markovnikov simply because they have the same degree of substitution. And however I do it, I am going to get, regardless, a mix of bromide. So you can, if you add the H here, then you're going to have the bromine here, or the opposite, and you get a mix of product. So that's a way to do it here. What we needed to be careful of is just two things. OH is a bad leaving group, so we need to make that a better leaving group to be able to do the elimination. And then the choice of base. The base needs to be chosen so that I get the size of alkene and then do the addition.